Hi, I'm Piper, and this is my Physics Lab 4 on oscillations. So the purpose is to predict the motion of our system with a spring and mass, where the mass oscillates in an arc, and we want to determine whether the model follows the energy principle. So I used Tracker to track the mass, and then I made a computational model of the system on GlowScript. The fundamental principles are Newton's second law and the energy principle. The system is the mass, spring, and earth, and the surroundings is nothing. And the results were that the energy principle is satisfied because the total energy of the system stays at zero. The total change in the energy of the system is zero. So our physics principles are Newton's second law. The system's change in momentum is proportional to the net force applied. And here you can see the equations for that. And the energy principle is that the system's change in energy is the sum of work done by the surroundings and the thermal energy exchange with surroundings. And here we can see that the total change in all of the energies will be zero. So some other equations we're going to use are the position update, the velocity update, some different energy formulas, and force formulas. So the initial conditions are the system is the spring, mass, and earth, and the surroundings are none. The work of the surroundings is zero, heat is zero, and change in T is going to be 0.095 seconds. The mass of the weight is 0.402, and initial position and velocity is around zero. So we want to find the spring constant. So to do that, we'll first find the oscillation period. So I took the 3 different periods and divided by 3 to get an average of 1.644 seconds. And then I solved for k using this equation, t squared equals 4 pi squared times m divided by k. And I found this. And then I solved for the relaxed length, which was 0.0275 meters. So for GlowScript, for the computational model, I put in the constants and the relaxed length of the spring, and I solved for S, which is the change in the length of the spring. And then here are my energy formulas I talked about earlier, which I put in. So here I have the force of gravity, which is just negative mg, force of the spring, F net, and then position update formulas and updating the spring. And then I also have the formulas for energy changes. So the computational model results show that the change in the energy was zero. And when I compared the computational model with the data from Tracker, it definitely did not line up right. So some errors that I could have had were that the system in real life is not isolated, so there may be other factors, or that I didn't place the center of mass right in Tracker. So for the questions, is the energy principle satisfied for the model system? The answer is yes. There are no external forces acting on the isolated system, so the change in energy is zero. And in this graph, we can see that the change in energy was zero. So the other question was to make 2 estimates of oscillation periods, first from x and the second from y. So here I have my calculation for the x direction, and here's my calculation for the y. So I found the periods in both and divided by 3 to get an average. And then I used the same formula from before to find the spring constant, and I got 2 different spring constants for each direction. So choosing different directions gives us different periods, which affects the spring constants and the graphs for each. And the affected spring constant will also affect spring force and potential energy.